Stephen Mackintosh here from modulouniverse.com. This is a video about fractals, one of my favourite topics in mathematics and one I always come back to when I teach both mathematics and physical sciences. Here I am in my garden just looking for examples in fractals because they're all over nature. What we're looking for here is anything that has a repeating structure. So something that from a distance will look the same as it does when you zoom in close to it. Now here's one of the best examples, a fern leaf. So if you look at the overall shape of the leaf and then we zoom in and we see that it's actually made of smaller copies of itself. In some sense, these copies are scaled down and rotated and joined together. The best examples like this of fractals have an almost infinite regression. As we zoom in closer, we see smaller and smaller copies of the object. And that's what I'm going to explore in a bit more detail. So far we've been talking about nature, but where does mathematics come into this discussion? Well, it turns out that using some very simple recursive functions, you can create amazing detail and beauty in the mathematical world. And here's a very famous example. This is the Mandelbrot set, defined on the complex plane, uses a very simple function, z squared plus c, starting at the origin. And it has this wonderful self-replicating nature. So as we move into the fractal and increase the level of detail, we see the same patterns repeating over and over. Now it takes considerable processing power and time for a computer to generate and render an image like this. The computer has to be left to fill in all the details and store them, and that allows us to perform something called a fractal zoom, which is what we're currently looking at. Now it's actually easier than you might think to generate your own fractals. You can do this using pen and paper, which I'm going to show you a little bit later, or in 3D using a computer. Here's some examples of fractals I've generated using Unity, and these are quite simple in nature. I'm taking basic geometric primitives, for example cubes, spheres, cylinders. I'm making copies of them, I'm scaling them, reorientating them, and effectively gluing them back together in a recursive manner. And by doing so you can create some quite wonderful shapes. So for this last part of the video, I thought it would be interesting to to try and construct our own fractals in 2 dimensions just using pen and paper. This is a great exercise to do with young children. It's very engaging and it provides a great bridge between the creative arts into mathematics. We're going to look at 3 specific fractals that are easy to create. One is a tree fractal, then the cock snowflake fractal, and finally the Sierpinski gasket. For this first fractal then we'll need a sheet of A4 paper in portrait orientation and a pen. And we begin by drawing a single line from the centre, taking up about half of the length of the paper. Then we choose an angle for her branches and we draw 2 more lines from the initial line at half the length of the original. And we repeat this process. So 2 more lines from the previous 2. We're now on iteration 3 on this particular fractal. And now moving into iteration 4, and you can keep going as long as you like, but what becomes apparent is that the amount of work increases exponentially, and that in itself is a really effective teaching moment. I eventually stopped drawing branches after about 6 or 7 iterations, and when you do decide to stop, it's always good to add some colour and flair. So you might want to add some green leaves like I've done here. What's also interesting is if you change the initial angle of the branches, you'll get very different looking trees. So it's a great fractal to experiment with. The next example is called the Koch snowflake, and it's the same setup as before. We're going to take a sheet of A4 paper. This time we're going to start by drawing a large equilateral triangle in the centre. And once we've done that, we're going to draw an upside down equilateral triangle to make this star shape. And ideally you're then going to rub out the inside lines, because we only want the outer lines and vertices to be displayed. So here I am rubbing mine out, and so probably a good idea to use pencil, or you could use some white fluid to do this as well. And once you've rubbed these center lines out, we're going to go into iteration 2. To do this, we take each line and we go a kind of third of the way along, and then we draw another equilateral triangle sitting on top. And then we once again rub out the inside lines to tidy things up. And here I am doing a further iteration, and what you find with the snowflake fractal is it very quickly becomes quite labour intensive, but with perseverance you can create some wonderfully detailed looking snowflake fractals. The last fractal we're going to draw today is the Sierpinski gasket, and we start again with an equilateral triangle, filling as much of the page as possible. And And once you've drawn that, you want to draw an upside down equilateral triangle embedded within the first, and make sure that the 3 vertices touch the edges of the first triangle. You then want to go into iteration 2 by drawing more upside down equilateral triangles within the right-sided equilateral triangles, and continue performing as many iterations as you feel like. Just like the snowflake fractal, the gasket becomes really hard to draw beyond about 5 or 6 iterations, at which point you might want to stop and add some colour and texture to the fractal. And this one really benefits from shading. Perhaps you could try different reds or greens, and it's a great fractal to scale up and could make a really good wall project. So I hope you've enjoyed this introduction to fractals, and if I've inspired you to create your own, either with pen and paper or on a computer, then I feel that this video has been worth my while. Thank you very much for watching.